Chinese ink is made of lampblack, which is burning of vegetable oil, and animal glue from horn or animal hides.
We use inkstone and bottle ink. The bottle inks are more commonly used because of its convenience and efficiency. It can be used right out of the bottle. Meanwhile, inkstones are very rare. It took around 7 stationery stores to find, and less commonly used because it takes time and effort to prepare. In addition, inkstones generally create better quality ink than bottled inks because of its purity.
There were 2 parts to our experiment. In the first part of our experiment, we used water, sulfuric acid, methanol, potassium iodide, and hydrochloric acid to test the solubility of one piece of inkstone in each of the solvents for 7 minutes. Each solvent is 1.0 moles per liter. We chose these solvents based on their pH levels: pH 1, pH 2, pH 3, pH 7, and pH 8. Our hypothesis is that the more acidic the solvent is, the more the inkstones will erode.
We did 3 trials for each solvent and measured the weight of each inkstone before and after the process. The control variables included calibrating the electronic scale when measuring each of the inkstones, have the same volume of solvent for each trial, and time the trial for 7 minutes. We observed that all the masses of the inkstones increased except methanol. As we predicted, sulfuric acid with a pH of 1, aka the most acidic, eroded the inkstones the best. After testing the solubility of the inkstones in different solvents, we further extended our experiment by painting stripes of Chinese ink combined with each solvent to test the quality of the ink. Although the sulfuric acid broke down the inkstones the best, we concluded that the potassium iodide produces the best quality ink because of its smooth texture and consistency compared to that of sulfuric acid.
The second part of our experiment was chromatography. Chromatography is used to separate substances and mixtures of various chemicals into their individual components. It can identify a chemical and separate it from a dense mixture of other chemicals and show it on the surface.
We tested various types of black ink. Starting from the left to right, we have the black marker, black pen, black inkstone, and liquid Chinese ink. As we can see here, the black marker spreads out the most, followed by the black pen and then the liquid Chinese ink. However, the ink from the inkstone did not spread at all, which shows that it is composed of fewer chemicals than the rest.
We did some research and found that Chinese ink is significantly different from Western ink in composition and its ability to last a long time without wearing off. Unlike Western inks, which fade away when exposed to light, Chinese ink retains their resilience after centuries of display.
Thank you for tuning in.